Bismillah, alhamdulillah, wassalatu wassalamu ala rasulillah. This is section 9.5 and it's about determinants and Cramer's rule. So first we will say how to evaluate a second order determinant. So what is the determinant of a 2 by 2 matrix? Now, with every matrix, with every square matrix, we associate a real number. And this real number is called the determinant of the matrix. So for this 2 by 2 matrix, A1, B1, A2, B2, the determinant is denoted by this symbol. We write it like this. And we define it to be A1 times B2 minus A2 times B1. If you multiply these two and subtract, you get a real number. So the value of the second order determinant is equal to A1 B2 minus A2 B1. So what do? You multiply A1 times B2, you put it here, minus A2 times B1. So evaluate the determinant of each of the following. You write it like this. This is the determinant. And it is equal to 5 times 3, which is 15, minus 6 times 7, which is 42. And the answer is negative 27. So the determinant of this matrix is negative 27. This is a 2 by 2 matrix. And this is a 2 by 2 determinant. Okay. How to evaluate this determinant? We multiply 2 times negative 5, that's negative 10, minus negative 3 times 4, that's negative 12. Negative 10 plus 12 is 2. So this determinant is equal to 2. Evaluate the determinants of each of the following matrices. This determinant would be equal to 5 times 10, that's 50. 6 times 9 is 54. So the determinant is equal to negative 4. This is a 2 by 2 matrix. And the determinant is, we write it like this with these symbols. 4 times negative 8 is negative 32. 3 times negative 5 is negative 15. So negative 32 plus 15 is negative 17. So you can see that the determinant could be a negative number, could be a positive number, could be 0. So please evaluate these determinants by yourself. Let me do this one for you. You notice that this is the determinant. Okay, now this is the symbol of the determinant. So I don't have to write it again. If he says evaluate this, I immediately multiply half times negative 3 over 4 minus half times 1 over 8. And this would be negative 3 over 8 minus 1 over 16. And if you add, you get minus 7 over 16. Now, we can use the determinants to solve linear systems. The method is called Cramer's rule. So we have a system like this, two equations in two variables. How to solve this system using Cramer's rule? We find three determinants. This determinant, we call it dx. This determinant, we call it d. This determinant, we call it dy. And this determinant, we call it d. How do we find d? It is the determinant of the coefficients a1, a2, b1, b2. This would be the determinant D. So for example here, use Cramer's rule to solve the system. So immediately I can find the determinant D, which is 5, 6 coefficients of x and coefficients of y. 5 times negative 5 is negative 25 minus negative 4 times 6 is negative 24. Negative 25 plus 24 is negative 1. So D here is negative 1. So now we know how to find the determinant D. How do we find the determinant dx? Well, we replace the x column. Here we have the coefficients of x, a1, a2. We replace this column by the constants, by c1, c2, and keep y as it is. So this would be dx. And dy, we do the same, but for y, we change the columns of y by the constants, and we keep the columns of x as it is. So this is d, this is dx, changing the x column, and this is dy, changing the y column. So here dx would be, this is a determinant. Instead of 5, 6, I write 2 and 1. Find the determinant. 2 times negative 5 is negative 10. Negative 4 times 1 is negative 4. Negative 10 plus 4 is negative 6. Once I have d and dx, I can immediately find the value of x. X is dx over d. So it's negative 6 over negative 1, so x is 6. And now I find dy. How do we find dy? We write the column of x as it is, but instead of negative 4 and negative 5, I write the constants, which is 2, 1. So what is dy? 5 minus 2 times 6, 12. 5 minus 12 is negative 7. Now I can find y. Y is dy over d. dy is negative 7. d is negative 1. So y is 7. And the solution set of this system would be the ordered pair 6 and 7. So that's the answer. Use Cramer's rule to solve this system. Immediately, I find D. D is the determinant 5 of 5, 3, 4, and negative 6. 5 times negative 6 is negative 30. 3 times 4 is 12. The answer is negative 42. The determinant dx. I write 12, 24 instead of the x column. Now, negative 6 times 12. That's negative 72. Minus 4 times 24. That's 96. Well, negative 72 minus negative 96 is negative 168. So x would be dx over d. And the answer is 4. So that's the value of x. dy would be, I keep 5, 3, but I change 4, negative 6, I replace it by the constants, 12 and 24. 5 times 24 is 120. Minus 3 times 12, 36. The answer is 84. So y would be dy over d. And the answer is negative 2. So the solution set of this system would be the ordered pair 4 and negative 2. So please do the same. Solve here this system using Cramer's rule. Find find dx, find dy, and then x would be dx over d, and y would be dy over d. And I can tell you the answer. The answer would be this ordered pair. Let us do this exercise. Notice the difference. Now here, the system is not written in this form. We have to write it first in that form. So we cannot now work as usual. We have to write the first equation as 2x minus 3y equals to 2. And the second equation, 5x plus 4y equals to 51. And now d would be 2, 5, negative 3, and 4. 2 times 4 is 8. Negative 3 times 5 is negative 15. 8 plus 15 is 23. What about dx? Replace the x column by 2 and 51. 8 minus negative 3 times 51 is negative 153. So 8 plus 153 is 161. So x would be 161 over 23, and the answer is 7. So x is 7. Let us find dy. I keep the column of x, 2, 5, and replace negative 3, 4 by 2 and 51. 2 times 51 is 102 minus 10. The answer is 92. So y would be 92 over d, which is 23, and the answer is 4. So the solution set consists of the ordered pair 7 and 4. So this is how to find the determinant of 2 by 2 matrices, matrix, and how to use Cramer's rule for a 2 by 2 linear system.